Hi everyone, I'm Deepak, and today I'm going to share some work on incorporating diverse user perspectives into toxic content classification. So in order to combat toxic content and online abuse, major companies have frequently turned to machine learning to help towards the automated classification of toxic content. And indeed, many of these automated systems are deployed today, and companies will routinely do press releases where you'll see headlines like Twitter automatically flags more than half of all tweets that violate its rules. And yet, at the same time, there is significant and persistent backlash against major platforms, arguing that they are not doing enough to moderate the toxic content that is plaguing their users, especially those historically at risk of having toxic interactions online. So what's going on here? Well, while automated classifiers may be good at identifying candidate content that violates platform rules, there are still loads of content that fall into what we'll call a gray area. Not abusive enough to warrant removal, but still enough to cause harm to some internet users. In essence, not every person, whether you're a user of the platform or the platform itself, necessarily agrees on what constitutes a toxic comment online. And given that there are these differences, in this work, we sought to answer a more fundamental question, which is, how do the diverse perspectives of internet users, everything from their personal identities to their online experiences, change the way that users interpret toxic content online? And understanding this is an important first step to building anti-abuse tools for internet users that actually meet the needs of an increasingly diverse internet user base. So how did we do this? Well, we conducted a survey of 17,280 participants from Mechanical Turk, and we asked participants to label the toxicity of 20 potentially divisive comments online. Each comment was labeled by 5 raters, and in total, we built a dataset of about 108,000 comments. In addition to asking for their perspectives, we also had each participant answer some demographic questions and tell us about their personal experiences with toxic content online. So our data set ultimately captures a diverse set of participants from varied backgrounds, and this forms the basis of our analysis. So what we found when we were investigating participants' toxicity ratings is that participants that are historically at risk of experiencing online abuse perceive higher amounts of toxic content. So for example, the odds that minorities, younger Americans, and members of the LGBTQ community perceive a comment as toxic is significantly higher than those who do not identify in any of those categories. Of course, it's not just their identities that play a role in this. Our participants' lived experiences also play a role in their perceptions of online toxicity. So participants who had been a target of toxic content online had a higher odds of rating comments as toxic compared to those who have never been a target of toxic content online. Conversely, participants who have seen toxic contents but have never actually been a target actually have a lower odds of rating a comment as toxic, highlighting that these participants may be desensitized to new toxic content or have simply a higher threshold for what is acceptable online. But the point here is that a user's identity and their lived experience plays a direct role in their perceptions of online toxicity. So we next asked, how can we account for these diverse perspectives? And our idea here is simple. Can we somehow personalize existing classifiers to help us overcome the ambiguities in toxic content classification for a diverse set of users? So what does that mean? Well, if you were to take a state-of-the-art classifier, toxicity classifier, and evaluate it on our data set, what you would see is a maximum performance of about 0.35 precision and 0.37 accuracy for users in our data set at the optimal decision threshold, the one that maximizes performance for the most number of users. Now, you can actually improve this by simply finding a decision threshold that maximizes the performance for each individual participant. So for example, instead of having a single decision threshold, say marking a comment as toxic if it's greater than 0.5 and not toxic if it's less than 0.5, what you do is you have a specific personalized threshold for per participant based on their individual toxicity ratings. And it turns out if you do this, your average precision and average accuracy increase dramatically, up to 0.6 precision and 0.68 accuracy. In our data set, 72% of participants experienced a performance improvement from the classifier, highlighting that simply just taking into account personal preferences goes a long way in automated toxicity detection. So ultimately, our findings suggest that current automated toxicity detection systems fail to generalize to a diverse internet user base. And as we're building new anti-abuse defenses, we should take into account those diverse perspectives in order to truly build tools that can protect all internet users. Thank you for your time.